So let us start with natural numbers first of all. The other name for this is counting numbers and cardinal numbers. Amika, bring a copy in front of you. Yes. Counting and cardinal numbers. Right? I'll send you the recording of the lecture also, right? So these are the names. Now, what are natural numbers? They are 1, 2, 3, 4, and so on up. So if I ask you, tell me the greatest possible natural number, what will be the answer then?
There is no answer. It will go on from infinity.
Yes, either you can say infinity or you can say CBD. CBD means, you will see this term in many exams. It means cannot be determined. Cannot be determined.
Okay, ma'am.
Right?
Okay.
Okay, so this is the thing. And okay, so natural number means either we can say them counting numbers, because whenever we count, we always start counting 1, 2, we always start with 1, right? So 1, 2,
Yes.
3, 4. That's why they are called counting number. And cardinal is synonym for counting. Correct? Now you
Okay, ma'am.
remember this 1, 2, 3, 0 is not included here. Why? Because whenever we start counting, we never say 0. We always start with 1. That's why they are known to be natural numbers. Are you comfortable with me?
Yes.
Okay. Now let us start with your another category, which is called whole numbers. Okay. Can you tell me the definition, please?
Zero to infinity is whole numbers.
Yeah, exactly. If we take 0 to this list, if we assign 0 to this list, 0, 1, 2, 3, 4, so on up to, we call them whole numbers. Whole numbers. Is it fine?
Yes.
Okay, right. Very good. Okay, now coming to even numbers. Even numbers. What do we mean by even numbers?
Any number in two table is an even number. Or anything ending with 2, 4, 8, and 0 and 6.
Exactly, exactly. Very good. So you have told me the divisibility rule of 2. So what we can say about even numbers? First of all the numbers which are coming in table of 2, table of 2, they are known to be even numbers, right? I'll take a minute. I'll take a minute. Just a second. I'm not comfortable while writing. I'll take a minute. Okay. So are you able to see a white page on your screen?
Yes, ma'am.
Okay, so far we have done natural numbers
Yes.
and whole numbers, even numbers. And we were discussing even numbers. So you told me that between. So you told me that all the numbers which comes in table of 2, they are known to be even numbers, right?
Yes.
Yeah, so even numbers are 2, 4, 6, 8, 10, and so on up to. Correct? Now,
Yes.
there can be one more definition, that any number which when divided by 2, which when divided by 2, remainder is coming as 0. If I'm writing
It's a,
any number and we divide it by 2, if the remainder is coming to be 0, then this number is called an even number. Can you
even.
see that?
Yes.
Okay. Can you tell me one thing? If I write this way, that let this be D, and this be A, and this be Q, and this be R. What is the name for this number? Yeah, you tell me. Is this divisor, dividend, quotient, and remainder? There are 4 terms. Can you tell me what is the name for this?
Dividend.
This is called dividend. Very, very good. Anamika, very bad. You are in class 5. Still, you don't know anything. Beta, you are not supposed to say anything, right? Now, what is this? This is called divisor, and this is
Quotient.
Quotient.
and
Remainder.
remainder. So every time now onwards, every time, I'll not say that this number, I'll say dividend. Correct?
Okay.
So we write a dividend here and divisor is 2. If we are getting remainder as 0, then this number, this dividend is called even number. Is it fine?
Yes, ma'am.
Yeah. So we can talk about even numbers in two ways. First one is that they come in 2 ka table, and the other thing is whenever we divide the number by 2, the remainder is coming out to be 0.
0.
Fine.
Yes, ma'am.
So if I ask you that this number 1, 5, 4, 2, 6, 8, 7, whether this is an even number or not, how can you determine that?
You don't need to check the whole number. You just need to check the last digit if it is an even number.
Just a second. Yeah. So we have a big number 1, 5, 4, 2, 6, 8, 7. So yes, Amika, can you tell me whether this is an even number or not?
No, it's not an even number. We don't need to check the whole number. We just need to check the last digit. It is, if it is divisible by 2, the number is an even number. If not, the number is not an even number.
So what can be said about this number, Amika?
It is not an even number because the ending number is 7 and 7 is not divisible by 2.
You will not say ending number, you will say unit place, right? So the number, the digit on the unit place should be divisible by 2. So now this is a digit only. So what should come here? What should come here to make it divisible by 2? Can you say it should be either 0, because 0 is divisible by any number. Is that fine?
Yes.
Correct? Yes, Kartike?
Yes, ma'am.
Yes, and please tilt your screen, Kartike. I can't see you properly. I want to see your notebook as well. Yeah, now this is fine. So it will be either 0 or 2 or 4 or 6 or 8. If the number is ending in one of these digits, right? Then we can
Yes.
say that the number is even, otherwise not, right? So this
Yes.
is not an even number, I can say that. So if I ask you if this is not an even number, then it should be what? Is there any other name for that? Yes, Amika?
Odd number.
Odd number, exactly. So whenever we have any number which is not divisible by 2, I mean, if I take a dividend and 2 is the divisor, and if remainder is coming out to be 1, remainder is not 0. So I'll say that this number, which is dividend star, is not divisible by 2. This is the term we use. Star is not divisible. Divisible, right?
Yes.
Divisible by 2. Guys, there is a difference between these two terms, divided by 2, divisible by 2. So let us see that first of all. So whenever, write down these two terms first of all, divided by and divisible by. What is the difference between these two? So divisible by 5 and divided by 5, I'm using these two terms, right? So if I ask you that 17 is divided by 5, we can divide any number with any divisor. We can divide any number with any other number, right? So here 17 is divided by 5. What is the quotient we are getting? 3. And what is the remainder we are getting, guys? 2. Is it fine?
Yes.
So I can say that when 17 is divided by 5, we are getting a remainder of 2. This is our remainder. This is our quotient. This is our dividend. And this is our
Divisor.
sorry, it should be D. And this is our divisor. Is it fine? Correct?
Yes.
Now coming to the second term. Now, if I say that 17, is 17 divisible by 5?
No.
No, exactly. Divisible means remainder has to be 0 always. Remainder has to be 0 always. Correct? So if I ask you, 4 is divisible by 2, you will say yes. If I ask you, 384 divisible by 2, 384. Is this divisible by 2, Amika?
Yes.
Yes,
Yes,
ma'am.
yes, exactly. Correct. So use these two terms carefully, right? So we were doing odd numbers. Now I can say if a number is not divisible by 2, if a number is not divisible by 2, then we'll say that number is an odd number.
Yes.
Correct? Now you can correlate. Or I also can say that if any number when divided by 2, you can see I'm using divided by 2. Any number can be divided by 2, whatever be the remainder. Now, this star is divided by 2, remainder is 1. If remainder is 1, then this star, this dividend, will call it odd number. Are you with me, all of you?
Yes.
Yes, exactly. So, Amika, Kartike, can you please tell me, Amika is saying that the remainder can be, because I have written 1, she's telling me that remainder can be 1, 3, 5, 9, and she has skipped 7. Is she correct?
No.
No, why so?
Because if the remainder is 3, it's not an odd number, because you can still come up to a less remainder.
Exactly, very, very good. So let us see what is the problem here. Guys, whenever you divide any number with 5, let us say any number like, let us say 27. So what can be the quotient? Can you say 5 will be the quotient? This is how we divide. Can you say that?
Yes.
Yeah. So we put 25 here, we take subtraction. What is the remainder we are getting? 2. Correct. Actually, this remainder, Amika, look here. This remainder is, whatever be the remainder has to be less than the divisor always.
Yes.
Divisor से छोटा होना चाहिए remainder always. You should know this. Correct? That remainder should be less than the divisor. So what can be the remainder if we divide a number by a 5? Whatever be the number here, I don't know the number actual number. So what can be the remainder? What are the possible remainders when we divide a number by 5?
1, 2, 3, 4.
0, 0 also, because the number can be divisible by 5 as well. Are you with me, Kartikeya?
Yes. 0, 1, 2, 3, 4.
Yeah, exactly. So it will be either 0 or 1 or 2 or 3 or 4. I have to stop here. Correct? Now, if I divide any number with the 7, now Amika, this is your turn. How many possible remainders are there?
7.
7. And they are?
0,
Yes.
1,
2, 3, 4, 5, and 6. We have to stop here. Can you say this, Kartikeya?
Yes.
Very, very good. So far we have discussed natural number, whole number, even number, and odd numbers. Now coming to one more very good category. I think you have done this. We call it prime number. Prime number. Correct?
Yes.
What do we mean by prime number? Any one of you? So
I
turn.
know.
Yeah.
Prime number
Uh-huh.
is that it only has 2 factors, itself and 1.
Before discussing prime number, let us talk about, because you are saying that you are saying a word factor. So let us discuss these two words. What do we mean by a factor and a multiple. Yeah. So let us discuss factor. Okay. Now, Amika, this is your turn. Can you tell me what do we mean by a factor?
Factor is a number which
Please speak loudly.
factor is a number which divides a number.
No, this is not the apt definition.
Like there is the number 12. So 6 divides 12. 12
Six.
is divisible by 6.
Yeah, exactly. So
6 is the factor of 12.
6 is the factor of 12 and 12
12
is
is the multiple of 6.
very, very good. So whenever you take any number, for example, Amika has taken 12. So she is saying that 12 is divisible by 6. Very good, very good. You're using new terms. 12 is divisible by 6. So this 6 is called factor. And this 12, we'll call it multiple. Correct? So 12 is a multiple of 6 and 6 is a factor of 12. Is it fine? So we can say that you write any number as a dividend, and if you're writing a divisor here and remainder is coming out to be 0, then this dividend is called what? It is called multiple. It is called multiple, and this is called factor.
Okay.
So now let us come to the the category we were discussing, that was prime numbers. Prime numbers. Okay, so Karthike, you told me that any number which is having two factors is called a prime number.
Yes.
Yes, so this is one of the definition. Or we can say that any number, write with me, any number which is divisible by 1 and itself only. Any number which is divisible by 1 and itself only, that is having only two factors, having exactly, rather, it should be exactly, having exactly two factors is called, write with me guys, is called a prime number. This is how a concept can be imbibed. Prime number. Correct. Any number which is divisible by 1 and itself only, that is having exactly two factors, is called a prime number. And what are those two factors? It is 1 and itself. Correct?
Yes.
Yeah. So can you give me some example, Amika?
It is 2.
It is 2 because 2 is divisible by, so I'm writing number here and factors here, right? So how many factors of 2 are there?
1.
I know that 2 is divisible by 1. Can you say that every number is divisible by 1?
Yes.
It comes in 1 ka table. Also, can you say that any number is divisible by itself also?
Yes.
Yes.
Yes. So every time you take, suppose 3. So how many factors are there? 1 and 3. But if we take 4, 1 and 4, they are automatically factors because we have done this, that 1 and the number itself, they are always a factor of the number. So except these two, do we have any other factor of 4?
Yes. 2.
2. So can you say this will not be a prime number?
It will
Yes.
not.
Yeah, exactly. This is a prime number. This is a prime number. Correct. We know the definition of prime number. Now, because you are comfortable with prime number, I guess. And as I told you that we should remember all the prime numbers from 1 to 100. Kartikeya, have you done this?
Little bit, like 2, 3, 5, 7,
Correct.
99.
99, bacha, this is not a prime number because it is divisible by
3
9.
and 9.
9, 11, 3. It comes in 3 ka table, 9 ka table, 11 ka table. And after 9, you have gone to 99 directly. What about the numbers in between?
I don't remember them.
Okay. So this is your homework now. You should remember all the prime numbers from 1 to 100. Right? From 1 to 100. Okay. So write with me. So how do we write counting? We always write this way: 1, 2, 3, 4, right? So we'll write this. Just a second, guys. So we'll write what? We'll write first line from 1 to 10 first of all. How many prime numbers are there? Can you say in this line we have 2, 3, 5, 7? Correct?
Yes.
What about 11 to 20? Write down this. Write on your book, copy whichever you are using. 21 to 30. So in each line you will write this way. 31 to 40. You make a table of that. 31 to 40, then 41 to 50, then 51 to 60. You'll go up to 100. Take your time to write that. Kartika, are you taking class on phone?
No, laptop.
Laptop. I want to see your copy. Whichever thing you're writing. This is no, I think I'm not able to see that. So on laptop, I think it won't be possible. So please carry on.
Done, ma'am.
Yeah, Kartike. So you have written all the prime numbers till 100? Or you have made a table?
Table.
Table. Okay, from 11 to 20, can you write all the, just a second, Kartike. Yes, yes, Kartike. So you can tell me all the prime numbers from 11 to 20. Yes, please.
I don't know them.
Okay, so let us try with me. What about 11? Can you think of any table where 11 comes except 1 and 11? 11. Can you say that all the even numbers should be skipped?
Yes.
Because all the even numbers are divisible by 2, except 1 and itself, they are divisible by 2. So we'll think only in odd, right? So the other number is 13. What about 15?
It is divisible by 3.
15, very good. So we should skip that. So after 13, we have 17, then we have 19. Now coming to 21 to 30. 21 to 30. Yeah. What about 21? Is it a prime number, Amika?
No,
Why?
because it is divisible by 7 and 3.
It is divisible by 7 and 3. Is it fine, Kartike? Karthik,
Yes.
sit properly, please. So 21 is not a prime number. Okay, 23. What about 25? Yes, Karthik?
It is divisible by 5.
5, exactly. Can you say that if I take any number which is ending in 5, whose unit place is 5, it will always be divisible by 5. Can you say that?
Yes.
Yes. So out of odd numbers, I can skip all the numbers which are ending in 5 as well. Is it fine?
Yes.
So after 23, I'll not consider 25. I'll directly come to 27. What about 27? Yes, Kartike, your turn. Is it divisible by any number?
It is divisible by 3.
3. Very good. So 27 is also out. So here we come to 29. Now, in the similar manner, we'll write 31 and 37. Very good, Amika. If you can tell me other numbers in 41 to 50, other prime numbers.
41, 43, and 47.
41, 43, and 47. Very, very good. And 51 to 60. Yeah, 51 to 60. What about you, Amika?
It's 51.
No, 51 is not a prime number because it comes in 3 table. 3 into 17 is 3 into 17 will give you 51.
53.
53.
59.
9. Correct. Have you copied it, Kartike? I need to erase this.
Yes.
Yes. So let us come to the remaining numbers. So till 60 we have done. I'm coming to the next line, 61 to 70, then 71 to your 80, then 81 to 90, then 91 to 100. Yeah, what about 61 to 70? Take your time now. Yeah, 61 to 70. Can you say 61, then 67? Now 71 to 80. It will be 71, 73, 79, 81 to 90, Amika.
Yes. 81 to 90. 83.
83, very good.
It will be
89. And in the last row, we have only one prime number, which is 97. 97. Write it down.
done.
Have you completed it, Kartike? Okay. Now we can do one more thing. Just write down all the numbers from 1 to 100. This is your food for thought. Okay? This will be your next class work. You will write counting till 100 in the same manner that you have done in your kindergarten. So we'll write the whole thing. Guys, can you say that every third number will be divisible by 3?
Yes.
Can you say this? Every third number will be divisible by 3. That is the meaning of table. We do tables, no? So every third number will be divisible by 3. You can see
Yes.
this 1, 2, 3, 4, 5, 6, 7, 8, then we'll get 9. This is how we write table. Every second number is divisible by 2.
Yes.
Every
Yes.
fourth number is divisible by 4 and so on. Correct?
Yes.
You'll do one thing by the next class. You will write all the numbers from 1 to 100. You will write the whole counting 4, 5, 6, 7, 8, 9, 10. This way 11, 12, 13, so on up to 20. then 21, 22, 23, so on up to 91, 92, 93, so on up to 100. Correct. Now we'll try to find all the primes. Though we have written it, but how can we trust that this is the list of all the prime numbers? Now we'll strike out all the numbers which are not prime. Kartika, are you with me?
Yes.
Yes. So can you say that every third number will be divisible by 3? First of all, every second number will be divisible by 2. So I should strike out these numbers because definitely they are coming in table of 2. So all of them are not prime numbers. Are you with me, Kartikeya and Namika?
Yes.
Yes, ma'am.
Yes. So in the similar manner, with a different colored pen, you will strike out all those numbers which are divisible by 3. But sorry, we should retain this 3. So 6 will be out. That is already out. 9 will be out. Then 12 will be out. Then 15 will be out. All the numbers which are divisible by 3. Is it fine?
Yes.
Similarly, except 3, definitely except 3, because 3 is coming at its place for the first time. So it is divisible by only 1 and the number itself. That's why we'll consider that as a prime. And all the numbers which are divisible by 4, every fourth number is a divisible by 4. And you can see all the numbers are deleted already. 4, 8. Karthika, can you say that every number which is divisible by 4 also divisible by 2?
Yes.
Yes. And similarly, every number which is divisible by 6 should be divisible by
2 and 3.
2 and 3. Its factor. Do you understand that?
Yes.
Yes. So any number, you take any number which is divisible by, say, any number, say n. N can be anything. It can be 17. It can be, so I'm taking a general number, right? So if there is any number which is divisible by n, let us take this number to be star. If it is divisible, then definitely the remainder is coming out to be 0. Now, can you say that if star is divisible by n, star will be divisible by its factor also? Do you understand this? Once again, write it with me. Okay. So you will write that 15, sorry, once again, let us take 30. 30 is divisible by 15. That we know. Is it a right statement that 30 is divisible by 15?
Yes.
Yes.
Yes. So if 30 is divisible by 15, can he say that 30 is also divisible by factors of 15?
Yes.
Can you say this now? So what are factors of 15?
3,
What?
5,
3 and
5.
3 and 5. 1 and 15 also, but we are interested in these new two numbers except 1 in itself. So what are the factors of 15? They are 3 and 5. Amika, do you get it? What I have written?
Yes.
Yes, that 30. If 30 is divisible by any number, then 30 will also be divisible by its factor. Is it right now?
Yes.
Yes.
Yes, that's why when we took this 1, 2, 3, 4, 5, while we were calculating all the prime numbers, we cancelled, we striked out all the numbers which were divisible by 2. 4 was out, 6 was out, 8 was out, 10 was out. So when we came to 4, can you say any number which is divisible by 4 surely is divisible by 2 as well? Now, can I say that?
Yes.
Because 2 is
Yes.
a factor of 4. Are you with me?
Yes.
Yes.
Okay. Whenever you find any concept difficult, you can speak up. Correct? Then I'll do one thing. I'll take a smaller example, or we can change the discussion. So whenever you get bored, please let me know. So that's why all these numbers which are divisible by 4, they were already out. 4 was out, 8 was out, 12 was out, because every fourth number is divisible by 4, and any number which is divisible by 4 is already divisible by 2.
And 8.
Yes.
Come again, Amika. Any number which is divisible by 4. Yeah. So what should be done?
2.
2. So any number which is divisible by 4 is also divisible by 2. You said 8, Amika. What is the meaning of speaking 8 here? I think you mean to say that similarly, all the numbers divisible by 8 are already out,
Yes.
because 2 is also a factor of 8. Very good. Is it fine?
Yes.
Yes, Kartike?
Yes, ma'am.
Yes, exactly. Very, very good. So far we have discussed prime number. Can you tell me all those numbers which are not prime numbers? Do we have any name for that?
1 second, ma'am. Just 1 second.
Yeah.
Yes, ma'am. I'm back.
Okay. So I was asking you, Kartike, that do we have any number, any particular name for all those numbers which are not prime numbers?
Composite numbers.
Yes, exactly. That's what I have written, composite numbers. So we talked about all the prime numbers from 1 to 100. Can you define them now? If I ask you, what do we mean by a composite number? I mean, I'm talking about the definition of composite number. Yeah,
Composite number is any number that isn't a prime number.
that isn't a prime number. Amika, is that correct definition? No. Why so?
Because composite numbers are numbers which have
Which have
2 or more factors.
2 or more factors? No, I can't say that.
More than 2 factors.
More than 2 factors, exactly. Kartike, what is the problem with your definition, bache? See, you told me that all those numbers which are not prime numbers, they are known to be prime composite numbers, right? Now, what is the problem with this? So, we have previously we wrote all the prime numbers from 1 to 100. Now, I'm going according to your definition, so I'm left with these many numbers. 1, then 2 is out, 3 is out, 4, 1, 4, then I'll take 6, then I'll take 8, then I'll take 10, and so on up. So according to you, this list will give you all the composite numbers. Am I correct according to your definition?
Yes.
Yes. But the problem is here with 1. Why so? Because 1 is what? 1. How many factors are there of 1?
1.
1, exactly. So what is the definition of composite number? Composite numbers, write with me, please. All those numbers which are having at least, do you understand this word at least? At least
Yes.
means come, say come. Now
Yes.
this is a good word. This word is used many times in mathematics question. So you should understand at least, at most, these kind of English words. So all those numbers which are having at least 3 factors.
3 or more than 3 factors.
Bacha, either you will say 3 or more than 3 factors, or you will say at least 3 factors. When you are saying at least 3 factors, both the things are already included here. Exactly 3 as well as more than 3. Is that fine?
Yes.
Is it fine?
Yes. Ma'am?
Yeah.
Oh, you are muted.
So all those numbers which are having at least 3 factors are called composite numbers.
Yes. Ma'am, I have a doubt.
Yes, you can ask.
What number is 1?
1 is, yes, write it down now. Now write down this also. 1 is a special number, special and only number, which is neither prime nor composite. Which is neither prime nor composite. Why so? Because I told you that while writing prime numbers, that the number of factors should be exactly 2.
Yes.
Correct? And in composite, number of factors should be exactly not exactly, greater than equal to 3. Do you understand these symbols? Definitely you haven't you have done these kind of symbols in your kindergarten. Greater than equal to 3, these many factors should be of composite numbers. Am I correct?
Yes.
Yeah. So what about 1? 1 is having how many factors? Only 1. That's why this is neither a composite number nor a prime number.
Okay. But
So,
which number is it?
sorry?
Which number is 1?
No, we don't have any name for this.
Oh, okay.
Huh. So Kartikeya, if I ask you that, yeah, from 1 to 100. So by the next class, you or both of you should remember all the prime numbers from 1 to 100. You learn it by heart. So I'll ask you the whole sequence, and definitely you will say that I'm telling you. How will I ask? So if my question is, can you tell me all the prime number from 1 to 100? So you will say yes, 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89, 97. So this is
Okay.
your first homework. Is that correct?
Okay, ma'am.
So you should remember all the prime numbers. The way you remember all the tables, right?
Yes.
Yes. So from 1 to 100, we have learned all the prime numbers and all the composite number. And we have learned that 1 is neither a prime number nor a composite number. Is that fine?
Yes.
Yes.
Okay, write it with me once again. That there are, Amika, how many prime numbers are there from 1 to 100? Yes, exactly. There are 25 prime numbers from 1 to 100. Yes, Amika.
If there are from 100, there will be
No, no,
20
no, no, no,
numbers.
no. Kartik Amika is asking if from 1 to 100 there are 25 prime numbers. So from 1 to 200, will there be 50 prime numbers? No, we cannot say that. I am not saying that in interval of 100 numbers from 1 to 100, in the block of 100 numbers, every time there are 25 prime numbers. No, this is not so. Correct? Every time we have to judge, we have to write, we have to calculate each and every number. We have to check each and every number. Correct? We cannot generalize this. Is it fine?
Yes.
Yes.
Yes. So, Kartik, there is a question for you that if there are 25 prime numbers from 1 to 100, how many composites are left from 1 to 100?
There are 74
74. Very, very good. So, how come 74? Please elaborate.
because 100 minus 25 75, but because 1 is not a composite or prime number, it is 74.
Very, very good. So, how many composite numbers are there from 1 to 100, Amika?
74.
74. Uh, 100 minus 25. So we are subtracting all the prime numbers, as well as we have to subtract 1, because 1 is neither a prime number nor a composite number. Is it fine?
Yes.
Okay. So if I ask you, greatest 2-digit prime number.
Greatest 2-digit 97.
97. What about you, Amika? 97. Greatest 2-digit prime number, 97. Okay. So if I ask you, smallest even prime number, Amika? Yes,
It's 2.
2. Smallest even prime number, it is 2. Now this is Kartika for you. Greatest even prime number?
2.
Sorry?
2.
2. So can you say that 2 is the only even prime?
Yes.
Write it with me. 2 is the only even prime.
Done.
2 is the only even prime. Correct, Kartike?
Yes.
So Kartike, I'll do one thing now. That's it for today. So we have discussed natural number, whole numbers, prime number, composite number, even number, and odd number so far. Yeah, still any doubt left in these kind of numbers?
No,
Amika?
ma'am.
No? Okay. After the class, you'll get a sheet. I think I have shared the sheet with your father. They were, I guess, almost 14 to 15 question in that sheet.
Yes.
Yes.
Yes. Have you done that sheet?
Not yet.
Not yet. So we'll have another class on coming Friday at the same timing, most probably. If there is any change, then I'll let you know. So you will complete that sheet by Friday, this coming Friday.
Okay.
So at the beginning of the class, I'll take doubts. And I guess by tomorrow, if you are free by tomorrow, you can share your answer sheet with me.
Yeah,
I
ma'am.
need, I need complete explanation. Why complete explanation, bache? I need your rough work to judge what you are doing. Correct? I need your rough work as well as your answers.
Okay.
So it's better if you take a copy and as you make a copy in your school, so you prepare a copy for that.
I'm already prepared.
Okay, you have already prepared. Very, very good. Okay, so I'll be putting this recorded video on YouTube. I'll share a link with you. So whenever you find any problem, you can go back to the video.
Okay, ma'am.
Okay. So thank you. Thank you so much.
Thank you, ma'am.
Okay. Okay, bache.
Bye, ma'am.
Bye, bache.